Okay, stoichiometry is converting moles of grams from one element to another element. So all it is basically conversion factors. So let's look at this example. 4 aluminum plus 3 oxygen gas will give us aluminum 2O3. 2 aluminum 2, yeah. So then if we are given 3 moles of aluminum and the problem asks for moles of oxygen gas, what we would do is bring down the given. So 3 moles of aluminum times the conversion factor to give it to moles. We find the conversion factor by putting what we want. We want to find moles of O2, so we put the coefficient on top. That way, so whenever we multiply it, we get rid of the moles of aluminum and we get moles of oxygen. So then we have to put what we have in our unit in the given into the bottom. So we have 4 aluminum, so we have to put 4 aluminum on the bottom. And this will give us moles of oxygen gas. So if we, hold on, my pencil broke. Okay. If we multiply this, we would get 9/4. That gives us about 2.25 moles of oxygen gas. So that would be our answer. That's probably the simplest it can get. Let's move to another problem. Moles to grams. If we are given 6 moles of oxygen gas and we need to get to grams of Al2O3, we would first bring down our given just like we did in mole to mole conversions. So that would be 6 moles of O2. We would times that by the mole ratio, which is we want Al2O3, so we put the coefficient of Al2O3, which is 2. So then we put 2 on top. Then we divide by what we have. So we put the coefficient 3 because we have moles of O2. So there, then we multiply to convert it from, so this is moles of Al2O3 and we want to get to grams of Al2O3. So we would multiply it by the mole ratio on top. So that would, or not the mole ratio, the molar mass on top. Multiply it, then divide by 1 mole. So that would give us grams of Al2O3. So if we multiply all that together, we get 1,223.52 divided by 3. And we roughly get 407.84 grams of Al2O3. That's another really simple problem, but some people can get confused on it, which is you only do 2 steps, kind of. You put the mole ratio to convert it from moles of O2 to moles of Al2O3, then you convert it to grams. And that's basically what this fraction does. So then if we're doing gram to gram problems, that would be pretty simple. You bring down our given, and if it's in grams, we have to convert it to moles in order to change it to different elements. So we would first put it into moles, which is, and we do that by putting moles on top and then grams on the bottom because we have grams being multiplied. So 26.98 is the molar mass of oxygen, or no, Al. So then you times that by the mole ratio, which is 3/4, because we want O2, so we put 3 on top, and then we have Al, so we put 4 on the bottom, so it would be 3/4. Then, now that this is in moles of O2, we want grams of O2 because it's asking for grams. So we would do the same thing we did here. We would take the molar mass and put it on top, and then divide it by 1 mole. Kind of like the opposite of this. So the molar mass of oxygen is 32, and then we divide that by 1 mole. this is going to give us grams of oxygen gas. So if we multiply that, that's 4,800 divided by 107.92. Then that would roughly give us 44.48 grams of O2. So that's basically it about stoichiometry. It's really simple, but it can get very complicated. I would recommend doing these steps. One, if it's asking for mole to mole, like we did here, all you would do is given times the mole ratio. Then that's our mole to mole. Now, if you're given moles and you're asked to go to grams, do the same thing here. Do step 1, then you would multiply by the conversion factor, which is molar mass divided by 1 mole. Okay, so then if you're asked for a gram to gram like we were here, all you would do is these 2 steps, then this 3rd step, which is 1 mole divided by molar mass. So it's basically just 3 easy steps. And if you keep these steps, it's gonna get easier and easier. So that's basically stoichiometry. It's just converting moles or grams to moles or grams of another element.